Hello, in this lecture we will find the value of DE. In the drawing we have triangle ABC. We know that side AC of triangle ABC equals to 2 units, side BC of triangle ABC equals to 8 units. We also know that line segment DE is parallel to AB, and we know that the size of line segment DE is a natural number. It belongs to the natural numbers, and we also know that this point G, is the centroid of triangle ABC. The centroid of a triangle is the point where the three medians intersect with each other. So at this point G, the three medians of triangle ABC intersect with each other. And actually the median of a triangle is for example, CF is the median of triangle ABC. That is to say, CF is a line segment that exits from the vertex C of triangle ABC and bisects AB. CF bisects side AB of triangle ABC. That is to say, CF, the median CF, divides side AB into two equal parts. That is to say, AF equals to FB. Okay, so the median CF bisects the side AB of triangle ABC. That is to say, AF equals to FB. Okay, AF equals to FB. So the median CF of triangle ABC bisects the side that it eats. That is to say, the median CF divides side AB into two equal parts. That is to say, AF equals to BF. And actually we have a rule that relates to the centroid of a triangle. We call it rule number 1. Rule number 1 states that in any triangle the centroid G divides the median in our example. The median is CF, so it divides the median CF in a relationship, in a ratio that equals to 2 to 1. So I will read rule number 1 again. Rule number 1 states that the centroid G divides the median, in our example is CF, the median is CF, so the centroid G divides the median in a ratio that equals to 2 to 1. That is to say that if CG equals to 2 units, then GF will be equal to 1 unit. That is the meaning of rule number 1, that the centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. Okay? So if CG equals to 2 units, then GF will be equal to 1 unit. Okay, that is the meaning of rule number 1. And we also can say that CG is twice as large as GF. Again, CG is twice as large as GF. So CG equals to 2 times GF. That is according to rule number 1. Okay. So we actually can implement rule number 1 in our drawing, because in our drawing we have the centroid G, and according to rule number 1, the centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF equals to 1 unit. And we also can say that CG is twice as large as GF. So if we define CG as 2x, that is to say, CG equals to 2x. So we actually can substitute CG in this equality by 2x, because CG equals to 2x. So we will get that 2x equals to 2 times GF. Here we will divide this equality by 2, and we will get that GF equals to x. We divided this equality by 2, and we got that GF equals to x. So we actually found out that if CG equals to 2x, then GF will be equal to x. So we can write here that if CG equals to 2x, then GF will be equal to x. Okay? And we actually have another rule. We call it rule number 2. Rule number 2 is valid in any triangle. So we can write here that in any triangle, so actually triangle ABC could be any triangle. Triangle ABC could be any triangle if we know that line segment DE so we can write down that if DE is parallel to BC, so if we know that line segment DE is parallel to BC, then the following equality is true. that AD over DB will be equal to AE over EC. I will repeat again. In triangle ABC, that could be any triangle, if we know that line segment DE is parallel to BC, then the following equality is true, that AD over DB will be equal to AE over EC. And again, we can implement rule number 2 in our drawing, because in our drawing we have the data that DE is parallel to AB. Because of the fact that DE is parallel to AB, according to what is given us in the question, we know that line segment DE is parallel to AB. Therefore, if we relate to triangle CAF, if we relate to the green triangle CAF, so in relation to triangle CAF, we know that DE is parallel to AB. Therefore, according to rule number 2, CD over DA will be equal to CG over GF. Again, in the green triangle CAF, we know that line segment DE is parallel to AB. Therefore, according to rule number 2, CD over DA equals to CG over GF. Okay, we'll add that is according to rule number 2. Okay, but what is the value of CG? The value of CG is 2x. And what is the value of GF? The value of GF is x. So we got that CD over DA equals to 2x over x. So x over x is 1, so x will get cancelled and we left only with 2. So CD over DA equals to 2. We found out that CD over DA equals to 2. Here we will multiply this equality by DA and we will get that CD equals to 2 times DA. Okay, CD is twice as large as DA. So if we define CD as 2y, that is to say, if CD equals to 2y, then we actually can substitute CD in this equality by 2y, because CD equals to 2y. We get that 2y equals to 2 times dA. Here we will divide this equality by 2, and we will get that dA equals to y. So actually we found out that if CD equals to 2y, then DA will be equal to y. Okay, so if CD equals to 2y, then dA will be equal to y. Okay, and we actually have another rule, rule number 3. Rule number 3 relates to parallel lines. Actually, rule number 3 states that corresponding angles between parallel lines equal to each other. Okay, corresponding angles between parallel lines are equal to each other. Okay, so I will read rule number 3 again. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So what does rule number 3 mean? Actually, the meaning of rule number 3 is that if we have two lines that are parallel to each other, that is to say we have, this is line A and line B is parallel to line A. This is line B. Line B is parallel to line A, and we have also line C that intersects with line B and line A. Line C intersects with lines A and B, and according to rule number 3, those two angles are corresponding angles, and rule number 3 states that those two corresponding angles that are located between the parallel lines A and B are equal to each other. So if this angle equals to alpha, this angle will be also equal to alpha. Why? Because of the fact that there are two corresponding angles that are located between the parallel lines A and B, therefore they are equal to each other. That is according to rule number 3. So those two angles are corresponding angles that are equal to each other. And we have another type of corresponding angles. If we have line A this is line A, and line A is parallel to line B. This is line B, and line A is parallel to line B, and we have line C that intersects with lines B and A. This is line C that intersects with line A and B. Actually, those two angles are defined as corresponding angles, and according to rule number 3, they are equal to each other because of the fact that they are located between the parallel lines A and B. So if this angle is better, this angle will be also better because of the fact that those two angles that are located between the parallel lines are equal to each other. So they are also the corresponding angles that are equal to each other, according to rule number 3. Okay? So that is the meaning of rule number 3, and we actually can implement rule number 3 in our drawing, because we know that in our drawing line segment DE is parallel to AB. It is given us the question that DE is parallel to AB. So because of the fact that DE is parallel to AB, then according to rule number 3, those two angles are corresponding angles, and because of the fact that those two corresponding angles are located between the parallel lines DE and AB, they will be equal to each other. So those two angles are corresponding angles, and they are located between the parallel lines, therefore they are equal to each other. Therefore, if this angle is alpha, then this angle will be also equal to alpha. So I will write it down. Angle BAC, this angle, equals to angle EDC, this angle, and both those two angles are equal to alpha, and they are equal to each other according to rule number 3. Okay, so because of the fact that DE is parallel to AB, then those two corresponding angles are equal to each other. That is to say, angle BAC equals to angle EDC, and both those two angles are equal to alpha. That is according to rule number 3, that corresponding angles that are located between the parallel lines are equal to each other. And we actually have another pair of corresponding angles that are also equal to each other. Those two angles are corresponding angles, and because of the fact that those two corresponding angles are located between the parallel lines DE and AB, they will be equal to each other. So this angle equals to this angle, and if we define angle ABC as beta, then angle DEC will be also equal to beta because of the fact that those two angles are equal to each other. So I write it down. Angle ABC, this angle, is equal to angle DEC, and both those two angles are equal to beta. So those two angles are equal to each other according to rule number 3 because of the fact that those actually two corresponding angles that are located between the parallel lines DE and AB, therefore they are equal to each other according to rule number 3. Okay, so angle BAC, angle ABC equals to angle DEC, and both those two angles are equal to beta. So those two angles are equal to each other according to rule number 3. Okay? So we actually found out that those two angles are equal to each other and they are both equal to alpha, and both those two angles are equal also to each other and they are both equal to beta. Okay, so in the next step we will focus on the big triangle, triangle ABC, and on the small triangle, triangle CDE. Okay, so we actually will prove that both those two triangles are similar to each other. So we will focus on triangle ABC and triangle CDE. Again, we'll focus on triangles ABC and CDE. We know that angle BAC, this angle, is equal to angle EDC, this angle, and they are both equal to alpha. Okay, so angle BAC of triangle ABC equals to angle EDC of triangle CDE, and they are both equal to alpha. We also know that this angle, angle ABC of triangle ABC, is equal to angle CED of triangle CDE, and they are both equal to beta. Again, angle ABC of triangle ABC equals to angle CED of triangle CDE, and they are both equal to beta. And we also have the third angle. We have this angle, angle C is a common angle. It actually belongs to both triangles. It belongs to the small triangle, triangle CDE, and angle C is also belongs to triangle ABC. So we can write down that angle C equals to angle C as a common angle that belongs to both triangles. Okay, angle C equals to angle C as a common angle that belongs to both triangles. So we actually proved that three angles of triangle ABC are correspondingly equal to the three angles of triangle CDE. Therefore, we actually proved that triangle ABC is similar to triangle CDE according to angle similarity rule. So I will write it down. So we actually proved that triangle ABC is similar, that is the sign of similar. Triangle ABC is similar to triangle CDE. According to angle similarity rule. Okay, I will read again the things that I wrote. Triangle ABC, the big triangle, is similar to the small triangle, triangle CDE, according to angle similarity rule. So what is angle similarity rule? Angle similarity rule is a rule that states that if you prove that three angles of one triangle are correspondingly equal to three angles of another triangle, you actually proved that both those two triangles are similar to each other according to angle similarity rule. Okay, so from the fact that triangle ABC is similar to triangle CDE, we can conclude the following equality, that CD over AC equals to DE over AB. Again, because of the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over AC equals to DE over AB. Okay, actually, CD is a side that belongs to triangle CDE, AC is a side that belongs to triangle ABC, and DE is a side that belongs to triangle CDE, and AB is a side that belongs to triangle ABC. So this equality is true because of the fact that triangle ABC is similar to triangle CDE. Okay, and what is the value of CD? The value of CD is actually 2y. The value of CD is 2y. And what is the value of AC? The value of AC is CD plus DA. CD plus DA is actually, CD is 2y and DA is y. So CA is 2y plus y. Okay, so in total we got that DE over AB equals to 2y over 2y plus y, or DE over AB equals to 2y plus y is 3y. So here we have y over y is 1, so y will get cancelled and we left only with 2/3. So in total we got that DE over AB equals to 2/3. Here we will multiply this equality by AB and we will get that DE equals to 2/3 AB. So we found out that DE equals to 2/3 AB. Okay, so in the next step I will present to you a new rule, rule number 4. Actually, rule number 4 is valid in any triangle. Rule number 4 states that the sum of two sides in any triangle is greater than the length of the third side. that is the first part of rule number 4. I will read it again. The first part of rule number 4 states that the sum of two sides in any triangle is greater than the length of the third side. So actually the meaning of the first part of rule number 4 is that if you have a triangle ABC, that could be any triangle, again, triangle ABC could be any triangle, and we know that side AB of triangle ABC equals to A units, and the size of side AC of triangle ABC is B units, and the size of side BC of triangle ABC is C units. Then, according to the first part of rule number 4, the sum of two sides of triangle ABC is A plus B, and rule number 4 states that sum A plus B is greater than the length of the third side, and the length of the third side is C. So according to the first part of rule number 4, A plus B is greater or bigger than C. That is the first part of rule number 4. And we have also the second part. The second part of rule number 4 is actually the difference between two sides in any triangle is smaller than the length of the third side. I will repeat on the second part of rule number 4 again. The second part of rule number 4 states that the difference between two sides in any triangle is smaller than the length of the third side. So if we look on the drawing, the difference between two sides of triangle ABC is actually A minus B, or we can also say that is the absolute value of A minus B. We will take the absolute value of A minus B because of the fact that if A is greater than B, then A minus B will be a negative number, and it is because we are dealing with the sides of a triangle, we should not get a negative number, so we will get the absolute value of A minus B. So according to the second part of rule number 4, the difference between two sides of any triangle, that is to say A minus B, is smaller than the length of the third side. And the length of the third side is actually the length of BC is C. So AB is smaller, or A minus B, or the absolute value of A minus B, is smaller than the length of the third side, that is actually C. So actually this inequality includes the two parts of rule number 4. The first part of rule number 4 states that the sum of two sides of the triangle is A plus B is greater than the length of the third side, that is to say A plus B is greater than C. And the second part of rule number 4 that is that the difference between two sides of any triangle, that is to say the absolute value of A minus B, is smaller than the length of the third side, that is to say the absolute value of A minus B is smaller than C. C is the length of the third side. Okay, so for one side the sum of the two sides is bigger than the third side, that is to say A plus B is greater than C. And for the other side, the difference between two sides of the absolute value of A minus B is smaller than the length of the third side, that is to say the absolute value of A minus B is smaller than C. Okay, so we can implement rule number 4 in our triangle ABC. So in triangle ABC, if we take the side AB of triangle ABC, according to rule number 4, AB from one side is smaller than the sum of the two other sides, that is to say AC plus BC. That is from one side, but from the other side, okay, so according to the first part of rule number 4, AB is smaller than the sum of the two other sides of the triangle, that is to say AC plus BC. That is the first part of rule number 4. And the second part of rule number 4 states that the difference between two sides of triangle ABC, that is to say the absolute value of CA minus CB, that difference is smaller than the length of the first side, that is actually AB. Okay, the difference between two sides of triangle ABC is CA minus CB, or the absolute value of CA minus CB, and that difference, or the absolute value of this difference, is smaller than the length of the third side, that is to say is smaller than AB. Okay, so actually this inequality is the implementation of rule number 4 in our triangle ABC. But we know that AC equals to 2 units and BC equals to 8 units, so we can write here that AC is 2 and BC is 8, so we have 2 plus 8 is greater than AB, and AB is greater than CA is 2 and CB is 8. 2 plus 8 is 10, so AB is smaller than 10, and AB is greater than the absolute value of 2 minus 8 is minus 6. So what is the absolute value of minus 6? The absolute value of minus 6 is, or the absolute value of any number, is the distance of the number from point 0, and the distance of minus 6 from point 0 is 6 units, so the absolute value of minus 6 is 6. So AB is bigger than 6 and it is smaller than 10. Okay, we got this inequality, but we have already found out that DE equals to 2/3 AB. Okay, you can see here that we have already found that DE equals to 2/3 AB. Okay, so we can write here that DE equals to 2/3 AB. So here we will multiply this inequality by 2/3. And we will get that 2/3 AB is greater than 2/3 times 6, and it is smaller than 2/3 times 10. We multiplied the equality by 2/3. Okay, so 2/3 times 6 is 2 times 6 is 12, and 12 over 3 is 4. Okay, so we got that 2/3 AB is greater than 4, and it is smaller than 2/3 times 10. 2 times 10 is 20, and 20 over 3 is 6.66. 6.66. So we found out that 2/3 AB is greater than 4 and it is smaller than 6.66. But what is the value of 2/3 AB? The value of 2/3 AB equals to DE according to this equality. So we actually can substitute 2/3 AB by DE because 2/3 AB equals to DE. So we will substitute DE by 2/3 AB, and we will get that DE is greater than 4 and it is smaller than 6.66. Okay, so actually after we substituted 2/3 AB by DE, we got that DE is smaller, DE is bigger than 4 and it is smaller than 6.66. But we also know it is given us in the question that DE belongs to the natural numbers. DE belongs to the natural numbers, that is to say DE of the size of DE is a natural number. What is natural number? Actually, natural number is a positive integer. Okay, so DE of the size of DE is a positive integer. Okay, so we know that DE is bigger than 4 and it is smaller than 6.66 from one side, but from the other side DE must be a natural number. So which natural numbers we have that are bigger than 4 and smaller than 6.66? The only two natural numbers that satisfy these requirements are 5 and 6. Okay, so DE equals to either 5 units or 6 units. And that is the final answer to the question, that the size of DE is either 5 units or 6 units. Here in the drawing we can see that line segment DE, this line segment DE is either equals to 5 units or 6 units. So the size of DE is either 5 units or 6 units. Okay, so that is the final answer to the question. And now I will summarize the lecture. Okay, so actually we wanted to find out the value of line segment DE, or the size of DE. We know that DE belongs to the natural numbers. And what is a natural number? Natural number is a positive integer. Okay, and we also know that side CA of triangle ABC equals to 2 units, and we know that side CB of triangle ABC equals to 8 units. We know that line segment DE is parallel to AB, and DE is a positive integer. And we also know that point G is the centroid of triangle ABC. What is the centroid? The centroid is a point where the three medians of the triangle are intersect with each other. So at point G, the three medians of triangle ABC are intersect with each other. And CF is actually the median of triangle ABC. Why CF is the median of triangle ABC? Because of the fact that it passes through the centroid of triangle ABC. And the median of any triangle is actually a line segment that exits from a vertex of the triangle and bisects the side that it eats. CF eats side AB of triangle ABC, therefore it bisects it. That is to say, AF equals to BF, or the median CF divides side BC to 2 equal parts. That is to say, AF equals to BF. Okay? So we want to find out the value of DE, or the size of DE. So we actually have the first rule number 1, that states that the centroid G divides the median CF in a ratio that equals to 2 to 1. So this centroid G divides the median CF in a ratio that equals to 2 to 1. That is to say, if CG equals to 2 units, then GF will be equal to 1 unit. According to rule number 1, if CG equals to 2 units, then GF will be equal to 1 unit. But actually, according to rule number 1, CG is twice as large as GF. So we can write down that CG equals to 2 times GF. Okay? And if we define CG as 2x, that is to say CG equals to 2x, then we can substitute the value of CG by 2x. Okay? Because CG equals to 2x. So we substituted CG by 2x in this equality, and we got that 2x equals to 2 times GF. Here we divided this equality by 2, and we got that GF equals to x. So we actually found out that if CG equals to 2x, then GF will be equal to x. So we can write here that CG equals to 2x, then GF will be equal to x. Okay? And we actually have another rule number 2, that is true in any triangle. If we have triangle ABC that could be any triangle, And in triangle ABC, we know that line segment DE is parallel to BC. If line segment DE is parallel to BC, then the following equality is true, that AD over DB equals to AE over AC. Again, in triangle ABC, if we know that line segment DE is parallel to BC, then AD over DB equals to AE over EC. Okay, so we actually can implement rule number 2 in our drawing, because in our drawing it is given us in the question that line segment DE is parallel to AB. Therefore, if we relate to the green triangle, in the green triangle we know that DE is parallel to AB, so according to rule number 2, CD over DA will be equal to CG over GF. Okay, because of the fact that in the green triangle we know that DE is parallel to AB, then according to rule number 2, if we relate to the green triangle, triangle CAF, CD over DA equals to CG over GF. But we know what is the value of CG. The value of CG is 2x. So here CG equals to 2x. And what is the value of GF? The value of GF is x. So we can write here that GF equals to x. So in total we got that CD over DA equals to 2x over x. X over x is 1, so x will get cancelled and we left only with 2. We got that CD over DA equals to 2. Here we multiplied this equality by DA and we got that CD equals to 2 times DA. And if we define CD as 2y, that is to say CD equals to 2y according to our definition, then we can substitute CD by 2y, because CD equals to 2y. So we will get that 2y equals to 2 times dA. Here we divided this equality by 2 and we got that dA equals to y. So actually we found out that if CD equals to 2y, then dA will be equal to y. So we can write here in the drawing that CD equals to 2y and dA equals to y. Then I presented to you rule number 3. Rule number 3 states that corresponding angles between parallel lines are equal to each other. So if we have line A that is parallel to line B and line C intersects lines A and B, actually those two angles are defined as corresponding angles, and according to rule number 3, those two corresponding angles that are located between the parallel lines A and B will be equal to each other. So if this angle is alpha, then this angle will be also alpha. That is one type of corresponding angles, and we also have the other type of two corresponding angles. We have line A that is parallel to line B, line C intersects the two parallel lines A and B. Actually those two angles are defined as corresponding angles, and because of the fact that those two corresponding angles are located between the parallel lines A and B, they will be equal to each other according to rule number 3. So if this angle is beta, then this angle will be also equal to beta. Okay, so we actually can implement rule number 3 in our drawing, because we know that it is given us in the question that line segment DE is parallel to AB. Therefore, according to rule number 3, because of the fact that DE is parallel to AB, those two corresponding angles that are located between the parallel lines DE and AB will be equal to each other. So If this angle is alpha, this angle will be also equal to alpha. So according to rule number 3, the corresponding angles BAC will be equal to the corresponding angle EDC, and the above will be equal to alpha. And we have another pair of corresponding angles. Those two angles are corresponding angles, and they are located between the parallel lines DE and AB, therefore they are equal to each other. So if this angle is beta, this angle will be also equal to beta because of the fact that those two angles are equal to each other. So we found out that angle ABC equals to angle DEC, and both those two angles are equal to beta. And actually, those two angles are equal to each other according to rule number 3. So we actually found out that those two angles are corresponding angles and they are equal to each other. They are both equal to alpha, and those two angles are also corresponding angles, and they are located between the parallel lines, and therefore they are equal to each other, and they are both equal to beta. Then we focused on the big triangle, triangle ABC, and the triangle CDE, and we proved that those two triangles are similar to each other. Why? Because we have angle BAC that equals to angle DEC, and both those two angles are equal to beta. And angle BAC equals to angle EDC, and both those two angles are equal to alpha. Okay? And we also have angle ABC that equals to angle CED, and both those two angles are equal to beta. So those two angles are corresponding angles, and they are equal to each other, and they are both equal to beta. And we have the third angle. The third angle C is a common angle. It belongs both to triangle CDE, and angle C also belongs to triangle ABC. Therefore, we can write down that angle C equals to angle C is a common angle that belongs to both triangles. So we actually proved that the three angles of triangle ABC are equal to the corresponding angles in triangle EDC. Therefore, we actually proved that the triangle ABC, the big triangle, is similar to triangle CDE according to angle similarity rule. And what is angle similarity rule? Actually, it means that if you prove that three angles of one triangle are correspondingly equal to three angles of another triangle, then you prove that those two triangles are similar to each other according to angle similarity rule. From the fact that triangle ABC is similar to triangle CDE, we can conclude that CD over CA equals to DE over AB. Okay? CD over AC equals to DE over AB. But what is the value of CD? The value of CD is 2y. Okay, so here we can write down that CD equals to 2y. And what is the value of CA? The value of CA is actually CD plus DA. That is to say, CA equals to CD, that is 2y, plus DA, that is y. Or in other words, CA equals to 2y plus y. So here we can write down that AC or CA is the same, equals to 2y plus y. So in total we got that DE over AB equals to 2y over 2y plus y is 3y. So DE over AB equals to 2y over 3y. Here y over y is 1, so y will get cancelled, and we left only with 2/3. We got that DE over AB equals to 2/3. Here we multiply this equality by AB, and we got that DE equals to 2/3 AB. Okay? Then I presented to you rule number 4. Rule number 4 states that the sum of two sides in any triangle is greater than the length of the third side. So the first part of rule number 4 states that if you have triangle ABC that could be any triangle, and we know that the size of side AB of triangle ABC equals to A units, and the size of side AC of triangle ABC equals to B units, and the size of side BC equals to C units, then according to the first part of rule number 4, A plus B is greater than C. Okay? The sum of two sides of triangle ABC is actually A plus B, and A plus B is greater than C. That is the first part of rule number 4. Then we actually have also the second part. The second part of rule number 4 states that the difference between two sides in any triangle is smaller than the length of the third side. So actually the meaning of the second part of rule number 4 is that the difference between two sides is A minus B, or the absolute value of A minus B, and that difference, or the absolute value of that difference, is smaller than C, smaller than the length of the first side, that is to say, is smaller than C. So in total, we got this inequality that summarizes the two parts of rule number 4, that A plus B is greater than C from one side, but the absolute value of A minus B is smaller than C. Okay, so we can implement rule number 4 in our triangle ABC. If we relate to side AB in triangle ABC, we can say that AB from one side is smaller than the sum of the other two sides. That is to say, AB is smaller than AC plus BC. AB is smaller than AC plus CB from one side, but from the other side, AB will be greater than the difference between those two sides. AB will be smaller than CA minus CB, or AB will be smaller, AB will be greater, it is smaller than AC plus BC, but it is greater than the difference between the two sides, that is to say CA minus CB, or AB is greater than the absolute value of CA minus CB. Okay, so that is the implementation of rule number 4 in our triangle ABC. But we know that AC equals to 2 units and BC equals to 8 units. So AC plus BC is 2 plus 8, so AB is smaller than 2 plus 8 from one side, but from the other side, AB is greater than the absolute value of 2 minus 8. The absolute value of, so 2 minus 8 is minus 6. And the absolute value of minus 6 is the distance of minus 6 from 0. The distance of minus 6 from 0 is 6 units, so the absolute value of minus 6 is 6. So in total we got that AB is smaller than 10 and it is bigger than 6 units. We multiplied this equality by 2/3, but we actually also know that DE, we have already found out that DE equals to 2/3 AB. Okay, so we can write here that DE equals to 2/3 AB according to what we have already found out. Here we multiplied this inequality by 2/3. We got that 2/3 AB equals to 2/3 times 10. 2/3 AB is smaller than 2/3 times 10, and it is bigger than 2/3 times 6. 2/3 times 10 is 6.66, and 2/3 times 6 is 4. So in total we got that 2/3 AB is greater than 4 and smaller than 6.66. But what is the value of 2/3 AB? According to this equality, the value of 2/3 AB equals to DE. So we can substitute 2/3 AB by DE because 2/3 AB equals to DE. So we substituted 2/3 AB by DE and we got this inequality that DE is bigger than 4 and smaller than 6.66. But it is given us in the question that DE belongs to the natural numbers. That is to say, DE is a natural number. What is a natural number? A natural number is a positive integer. So we know that DE must be a positive integer. So which natural numbers we have that are bigger than 4 and smaller than 6.66? The only two natural numbers that satisfy these requirements are 5 and 6. So we actually found out that the value or the size of DE is either 5 units or 6 units. So in the drawing we can see that this line segment DE, this line segment is equal, according to our answer, either to 5 units or 6 units, or the size of DE is equal to either 5 units or 6 units. And that is the final answer to the question. Okay, thank you very much.